1, 2, 3, 4. Okay? Now, method 2 is a little bit more complicated to think about, but it is easier, in my opinion, to do. Okay? So method 2 involves using this idea right here. And what that idea says is it says f of negative 1 at p, so the derivative of the inverse at p is the same as 1 over the derivative of the function at q. And remember, p and q is our original point, so q and p is the inverse point. So here's how you go about doing that one, okay? So what you do is you start with your original equation. So we start with y equals x to the 5th plus 2x minus 1. So just like you would in any other problem, you just take your derivative. Okay? So let's take our derivative. But remember, we already know our original point and our inverse point. So we can go ahead and start this. That is always your first step. Figure out your original point and figure out your inverse point. But in this juncture, we're going to just start taking the derivatives. We're going to do y prime equals 5x to the 4th plus 2. Okay? So using our original point, okay, we are going to plug in our x value. So our original point the original point is 0, negative 1. So we're going to plug that into our equation. So we're going to do y prime equals 5 times 0 to the 4th plus 2. So with y prime, we end up with y prime for the original function is 2. So what do you do now? How do you find the derivative of the inverse? Well, the inverse derivative is the reciprocal of that. So if this is the derivative of the original, then the derivative of the inverse is going to be, so f prime of negative 1 at p is going to equal 1/2. Okay, so you take the reciprocal of that. So let's go through and let's try a little more complicated problem. So we're going to do one more, and we're going to do one more, and it looks just like this. And I would like to zoom out just a little bit. So I'm going to take you through this problem, and let's kind of talk about how this works. So let's use both methods again. So the first one is, let's just kind of read the problem and see what it says. So it says, find f, let f of x equal this function. And what this says right here is this says to find, again, the derivative of the function, the derivative of the inverse, I should say, inverse of the function at x equals 2. Okay? So here's what you know. So the first thing is always to figure out what your points are. Okay? So step one always is to figure out what your points are. So here's what you have. So we have the original and we have the inverse. Now, you need to read what this says. So this says the derivative of the inverse at x equals 2. So what that tells us is our x value for the inverse is 2. The way this is written, this is the derivative of the inverse at x equals 2. So that means the x equals 2 is the 2 for the x value in the inverse point. What does that mean then for the original? that means the y value for the original function is 2. But we need both of these. So in order to calculate or figure out both of these out, we are going to actually have to use our graphing calculators. So if you see a problem like this, you are going to need to have a graphing calculator. So what I'm going to tell you is I'm going to show you how we figure this out. So the first thing you should do is on your graphing calculator, you're going to type in the original graph. Okay, so notice it is x to the third plus 2x minus 1. So y equals x to the third plus 2x minus 1. So that is our original function. Okay, so because that's our original function, I'm going to graph it. And I like to use a standard window. So we graph the function. We have x equals, or y equals x cubed plus 2x plus 1. So we need to figure out what the x value for the original is. But notice, for our original function, y equals 2. So I'm going to go to y equals again, and I'm going to put in 2. So I want to find the x value where y equals 2. So let's graph that. So in order to figure out the x value, so here's y equals 2, I want to figure out where the x value is. And looking at the graph, I can see that it's kind of 1, but I want to verify it. So I'm going to go to second, calculate, and I'm going to use intersection. So I pick my 2 lines, and I guess, and there it is. So the point is, for the original function, the point is 1, 2. So that means for the inverse, the point is 2, 1. So this is always your first thing that you need to do when you are going to try to figure out the derivative of inverses. You need to know what your original point is, and you need to know what your inverse point is. So let's go through method 1. Method 1 is the interchange method. So when I say interchange, I just simply mean we're going to switch the x's and the y's, and then we're going to do implicit differentiation. So I'm going to take this equation, and I'm going to switch the x, and I'm going to switch all of the x's and y's to different values. Okay? So we'll split all of those up, or we'll interchange all of those things. Now, the second thing is take the derivative. Okay? So take the derivative of each of these. But remember, it's always with respects to x. So it is implicit differentiation. So the derivative of x is 1. The derivative of y cubed is 3y squared. But remember, I also need to multiply it times y prime. And then the derivative of 2y is going to be plus 2. But remember, I also need to multiply it times y prime. And then the derivative of negative 1 is 0. Okay? Now, what we need to do is we need to get the y prime by itself. So we're going to take out our y prime, and we're going to do 3y squared plus 2, and then divide to get that by itself. So now, use your inverse point. So we now know what our inverse point is. That is why it is so important that you figure out your inverse point, because this now is your y value. So your y value actually is 1. So we plug that in, and we're going to have 1 over 3 times 1 squared plus 2. So it ends up being 1/5. Okay? So our final answer using the interchange method is 1/5. So this is the more, in terms of doing math, it's the more straightforward. Just interchanging the two, it takes into the account of this idea of just switching the x's and y's. Take your derivative, and then, but you need to remember you have to figure out what your inverse point is. So now let's go to method 2. Method 2, again, just says the derivative of the inverse at x equals p is equal to the reciprocal of the derivative at x equals q. So that's what it means in words. So how do you go about doing that? So what you're going to do is we're going to just start with the original equation. So with this method, you start with your original equation, and we take the derivative of that. So let's just find y prime equals 3x squared plus 2. Okay? And this is for our original equation. So this is using the point 1, 2. Yes, so this is using the point 1, 2. So now, let's go through and find what the slope is, or the derivative. So let's do y prime equals 3 times 1 squared plus 2. So y prime equals 5. Now, here's the thing though. It's asking you for the derivative of the inverse at x equals 2. So remember, the inverse point is 2, 1. So that means our x is 2. So what we do is we just take the reciprocal of the original derivative, which is 1/5. So this is our final answer. Okay, so at 2, 1, the reciprocal is 1/5, and that's what our slope is. So either way works when you're going through and trying to calculate the derivative of an inverse. So that's what we're looking at. Those are the 2 ways to find the derivative of inverses. So please go through, watch these videos, and we will do more with this in the upcoming days. Hope you have a great day, and I will talk to you sometime later. There we go.